all tired out. Microphone. Can I get a show of hands? How many people here are Inventus employees? Just curious. In the back of the room. Okay. How many are partners? Okay. Thank you. Do we have any customers or users in the room? Okay, thank you. I was just curious to see what the mix was so I can get a feel for what kind of questions we're getting. Well, I'm going to talk about, my name is Wade Mattar. I am the, you remember me from last year as the Flow product manager. Now I just shepherd the Vortex and Coriolis lines. We hired a product manager to concentrate on MAG. So that's why we're able to do some of the things Vinny showed you, well, some of you showed some of you, to make the MAG product a little more suitable for the European market. And he's a European. So that'll be something that we're going to be able to start talking about in the next year or so. And so I'm sure you're all happy to hear that. Well, you all know, I bet there's no one in this room that hasn't seen this movie. But that's how a Vortex meter works. I'm going to talk about Vortex, something new that we've done in Vortex, be coming out in December. Something that's going away in Vortex that you need to know about if you don't know about it already. And then I'm going to flip over to Coriolis and do the same thing, talk about something new that we've just released. I hope you're all aware of in Coriolis as well. So there's the vortex shedding. It's usually dangerous to show this film after lunch. So I'll move. Okay, you all know the advantages over turbine, over orifice plate. You've heard this before, but just to reinforce, the reason the vortex meter is starting to grow, it's growing at a rate higher than the industry rate for instrumentations. It's a relatively small market in the $250 million range, but it's growing much faster than some of the other of the traditional flow measurement devices. And the reason is it's much more cost-effective for a user to deal with a frequency device that has no moving parts. In fact, Europe has been very successful in selling our vortex meter. So you're all very familiar with that. And of course, orifice plate is, no offense, Pat, but the orifice plate is really the old device. There's more orifice plates out there than any other flow meter on the planet. But there are a lot of places where Vortex can easily supplant orifice plates. Now, we tout the Model 84 as having the best performance, widest flow range available in a Vortex flow meter. Why do we say that? The answer is this direct sense technology. How many people use this argument when they sell a Vortex meter? Please do, because it is a real differentiator in the marketplace. In fact, a lot of the competitors will try to paint this as a negative, when in fact it's the reason we have the highest performance out there. And there's all the things you have heard us say over the years. And this you've seen, there's the competitive meters. See, if there were users in the group, I would have probably blasted by this, this slide. So you can see that just about every competitive meter out there has some kind of claptrap. We call it claptrap. I don't know how that translates, but a lot of mechanical linkages and levers to get the pressure out of the pipe and into the electronics. We directly measure the vortex shedding. So our advantage is that we are in the process with the sensor, and we have a sensor that can live there for many years, as you all experienced, I'm sure. This you can get from the PSS. Just to remind you, we have a pretty broad line of vortex meters. sizes and such. I'm not going to go over the DTMs. You're going to hear something about DTMs from Dave, but like the DTM that Joe showed, we have a very rich certified DTM for our Vortex meter. And it turns out every Vortex meter, they all look alike, they all have the same, what's it called, style. We have a style guide for DTMs. But every time we release a new product with a new DTM, we end up adding some kind of an improvement in the process. And the latest one is the one Joe showed you. Hopefully you're all very adept with Flow Expert Pro. It's an online tool. In fact, it's so useful that many times our competitors use it. Typically better than the tools they have. A lot of times they'll have something that they give to a customer that isn't, as soon as you give one of these things to a customer, by the time he actually fires it up, it's already obsolete. So my advice to you, this is an online tool, my advice to you is, I hope it's on all your desktops already. I hope you encourage your customers to put it on their desktop, because it has a complete wealth of equations of state. We have a question, Mark?
Is there anything in the program to include two-phase flow within that program?
We've been asked for that, and it's a difficult thing to do because two-phase flow is a multi-dimensional situation. We've talked about it, we just don't have a real plan yet in the near term to do that. But any feedback from anyone here to add two-phase flow for the Coriolis meter, obviously, I assume you're talking about, please forward those things to us, because I work closely with Dave. Dave also is responsible for this program, and I work closely with him to add whatever features you folks ask for. I assume what you want is pressure drop, primarily.
Well, it's just that I don't know how easy it is to include it, but obviously, depending on the percentage of entrained air within the unit, it's just a difficult answer to give to a customer.
A rule of thumb that we've found out, for at least for the low viscosity liquid phases, if you have about 15 or 20% void fraction, you can take the Flow Expert Pro number and double it, and that would be the pressure drop. It's a rule of thumb. So there is an appreciable increase in pressure drop due to two-phase flow. Now that's only continuous two-phase flow, obviously. Okay. We've released about a year and a half ago, maybe 2 years ago, a low power vortex meter. This one, what was a relatively small addition, with some additions we made to it in the software world, has increased our volume in vortex in 1 year by 50%. For use in produced water, upstream oil and gas, oil fields. So, again, we have a relatively, for considering all the numbers you've heard you'll hear over the next 2 days about Emerson and Yokogawa and E&H, we have a relatively high market share, particularly in some of the regions of Europe and in North America. But we were still able to increase the volume by 50%. If you have any questions about that particular application, see me either this week or send me an email. This is the reason for this presentation on Vortex is, as of December release of bioautomation, there's still some minor possibilities we won't make it. But that doesn't mean you can't start quoting jobs. We're going to release the 3/4 inch, the 2, 3, and 4 inch, so the 50, the 80, and the 100 millimeter meters up to class 1500 and PN 160 as standard in stainless steel. And it'll have ATEX, it'll have the certifications you need. Okay. Shortly after that, probably before mid-year of the following year, we'll add duplex steel, which is very, very important in Europe. I'm sure you're finding that out. And Hastelloy C, the equivalent of Hastelloy C. Okay? And by the way, also the rest of the sizes from 3/4 inch to 12 inch. So we're very excited about this, and you'll see, hopefully you'll see it in the December by automation. You'll definitely see it in by the February by automation. I won't know till about 2 weeks from now whether manufacturing is ready for me to release it. By the way, SEMO, you're getting your PN25s. SEMO's been asking me for PN25s forever, and this includes PN25s, which we didn't have before. And so I guess that's about all I want to say about that. And like I said, you'll see it in December, or you'll see it in, oh, I did want to say something. How many people bought an ECP for high pressure? From that guy in the corner. How many haven't bought it, sold one because it was just too expensive? I'm sure there's a lot more experience with expensive ECPs. This will drop the cost of a PN160 meter by anywhere from 50% to 75%. Just so you know, the cost difference is huge. Also in December, how many have seen the notice that the Model 83, or have been alerted to the fact that the Model 83 in Hart and Foxconn is being pulled out of bioautomation in December as well? Now you heard, my colleagues saw it. Well, it is being, of course, the replacement for the Hart 83 is the Model 84. The replacement for the Foxconn is also Hart, but like the story Pat gave you about, we're pulling it out of bioautomation because we don't want to give mixed messages about starting new installations with Foxconn with the Vortex meter. So what we're doing is we can still support it, in which case you have to come to me first, just like you would for Pat, if you have a specific need for a Model 83. By all means, please move your customers, if you haven't already, to Model 84. The Model 83 analog will continue. We're exploring, Rick and I are exploring going up to sizes up to 16 inch. So one favor you can do us is give us some feedback if you see a need for a Vortex meter in that size range. This is how we're doing it. How we're doing the high pressure stuff is by changing how we design the structure. Flanges on, basically a flange on last construction. And it makes it very flexible, and specials, hopefully, eventually, specials will all go away and they'll all be standard product. Okay, how's the Coriolis meter work? You've probably seen a lot of different ways, even from me, a lot of different ways of describing Coriolis. But let's take a piece of pipe and do this. Flow wants to go straight. You rotate the pipe. The flow is going to hit that side wall, right? And it's going to introduce a force on that side wall because you're trying to turn it. You oscillate it the other way, and the opposite force is going to happen. So you're going to end up with an oscillating force that's proportional to the mass flow. Can you see that motion? By the way, all these movies are available to you to show to customers if you have to explain Coriolis. I don't know how often you have to do that. I don't know how often they care about how it works. But this is one of the reasons I'm showing you this, is because I'm going to talk about a new verification system we have in the CFT51 that requires, to understand it requires a little bit of knowing how a Vortex Coriolis meter works. You're gonna hear me say Vortex and Coriolis back and forth a lot. So, you've all seen this, I assume. You all know why Coriolis is so popular. True mass flow meter. It measures volume flows of single-phase fluids as good as any volumetric flow meter, pretty much. It's mass-based. It's good for concentration measurements. We don't promote it as much for its other feature. It's completely independent densitometer. Of course, you know that, but most of our literature concentrates on the mass flow aspects rather than density aspects. But certainly a lot of your customers buy them just for density measurement. You already know this. You already know what I've written there, what it can do. You also know that traditional Coriolis meters have trouble with two-phase flow. You already know that. Your customers know that. Anyone who's ever used the Coriolis meter knows that. A major user in North America, this is a quote from him. Most of the calls I get from the plant, he's the instrument guy, the head instrument guy. Most of the calls I get from the plant are Coriolis related, and 90% of those involve gas entrainment of some form. He works for a company that does dosing, small batches, things like that. So what we've done with digital Coriolis, you've heard the term digital Coriolis, everyone calls their device digital, and I'll talk about that in a minute. We improved the measurement precision, more stable zeros. We can continually operate, essentially from full to empty back to full. Continue to operate. I know you're asking what's the accuracy, but that's going to depend largely on the actual application. It's great for batching. Virtually unstallable. You know what stalling means. It gets unbalanced and it just can't vibrate anymore. Can't deliver enough power. Virtually insensitive to that. And its response time, its true response time, not how quickly it sends out a measurement, how quickly it responds to a change in the process, is better than 20 milliseconds, which is at least 5 to 10 times faster than any other Coriolis meter. Okay, why are we the only true digital Coriolis meter? And we've patented this approach. The reason we're the only true digital transmitter, because everyone's got a microprocessor in their Coriolis meter, is we've taken traditional Coriolis meters, the digital to analog interface is right here. We have a flow tube control, a flow tube, and then we go from analog to digital, and we do all our calculations. Everyone does that. All the Coriolis meters on the market do that. What we've done, we've moved that interface to here. The only thing that's analog in this device is the coils that are on the, you can see them over there after, the coils that are on the flow tube. That's the only analog part of our device. So if anyone asks you, everyone's digital, you can explain that this allows us to get more precise flow tube control in chaotic flows. What's a chaotic flow? Crazy flows. Flows that are typical in two-phase flow. Okay? And start from empty as well. Here's a bunch of applications. You've probably already seen the application notes on all of these. If you haven't, they're available on the sales portal or whatever website you commonly use. A couple of these things Rich is actually going to be talking about, like the net oil system. We're very successful right now with measuring in the States, with measuring milk, custody transfer milk off of trucks. I know it's a little more of a challenge to win that business in Europe, but we'll work with you to do that if you see a need here. CFT51. Everyone knows about the CFT51, I assume. What the CFT51 adds a lot of enhancements to the CFT50. It's all the goodness of the CFT50. But in addition, it allows you, and this is important for Europe, it allows you in minutes to replace the electronics. Right now, if you have failure of a CFT50, what do you have to do? Either have a spare or send it back to Foxboro, because it was just not something that was field repairable. Now, I actually, personally, who's not very good at this, personally, I replaced that electronics in under 5 minutes. That's how easy it is to do. And we turned the termination compartment 90 degrees so that it makes the thing bigger, but it allows the operators, the installers, to get access of everything from the front, which has been received very well from most of the people that have tried it so far. Someone mentioned brackets. This has one of the best brackets we've built. You can mount it to a pipe, you can mount it to a wall, you can mount it anywhere. So it has, and this is a bracket you'll get with the device. So it's very easy to install. We have this online verification procedure, which I will explain in a minute, which is becoming you heard about the NAMR 107, and you've also heard CDIPTA talk about, was it CDIPTA? This morning you heard them talk about diagnostics and predictive kind of diagnostics. Coriolis meter, our Coriolis meter looks like this. Just keep an eye on that A, B, C, and D. Please, you don't have to remember all this, but for those of you that are interested in this, or if you get into a situation where you have to explain this verification procedure to a customer, then just give me a holler and I'll help you through that. Basically, a vibrating, oscillating Coriolis meter has two fundamental modes of vibration. Each one has a different frequency. Because we have two drivers, we're able to excite both of these ourselves. So we've introduced a function that you have to stop the measurement, but we've introduced this function that your customer could use annually, every 6 months, every 2 years, to excite this, initiate it. And what it'll do is it'll measure each of these frequencies. The normal drive frequency and what we call the Coriolis frequency. And then it'll take a ratio. And that ratio is our validation number. Why would R vary? R is virtually independent of pressure, and I'll explain why I'm going through this slide. Virtually independent of pressure, temperature, flow rate, and density. It's only dependent on erosion, coatings, and corrosion. Now you notice I said difference in each of these. It assumes that you're going to get more erosion on the curved sections than the straight sections, and that's what it relies on. So it's a tractable quantity under process conditions. Other Coriolis manufacturers say they have verification procedures, but their procedures are sensitive to pressure, temperature, flow, and density. Ours is not. We've released a Modbus Verification DTM, which does two things. One, it excites this function for your customer, but more importantly, it produces a report that they can use in their auditing trails of whether there's been a deviation in that R quantity. And they can put this in their records, they could show it to agents, that sort of thing. One thing I just wanted to mention, a 1% deviation in that that R will produce a 2% error of the measurement. So this is important stuff for the customer.
Okay, cool. Well, thank you very much, Wade. Just before we finish it up, okay, thank you, Wade.